Hello again. Okay, so in this video, we're gonna take a look at how to simplify radical expressions. Okay, so first of all, let's try to understand what's a radical expression. Okay, so a radical expression is any expression that is under. So let's say you have a, b, something, and it's under a symbol that looks like this. Okay, so this symbol, this entire thing is a radical expression. Now, this symbol means what you have is a square root, okay? But sometimes you will see a number under this, so inside this little nook, okay? So then that number out here tells you that it's a cube root. So if it's a 3, it's a cube root. Sometimes you might see something like this, a 4. Well, that means it's a fourth root. And if it's a 5, it's a fifth root, and so on, okay? So anyway, the goal out here is to simplify radical expressions. So let's take a look at an example. So let's say you're given 3 square root of 2 plus square root of 2. So to simplify this, it's essential to understand that you have the same number, under the same radical sign. And what that means is, if you just think about this for a second, let's say if I had given you 3x plus x, then that would simplify to 4x, right? Because you just add the coefficients because they're like terms. So you treat it like a like term. So if you think about, if I told you that x was equal to square root of 2, well, then guess what? Then if I replace x in this with the square root of 2, then I get 3 square root of 2 plus square root of 2, which gives you 4 square root of 2, because I'm just looking at the coefficient of the square root because this is the x, right? So we're going to apply the same logic out here. So 3 plus square root of 2 plus square root of 2 is 3 plus 1 square root of 2, which is 4 square root of 2. And there you have it. Okay, so let's take a look at something similar. 3 square root of x plus square root of x. Go ahead and try this yourself. Pause the video. All right. So this one is similar. So now you have x squared of x, so you treat it the same. So this entire thing is a variable. You have a 3 coefficient out here, you have a 1 out here, so you just add them together. So that's 4 square root of x, okay? Let's take a look at one which is a little more complicated or a little more complex looking than the previous problems. So let's say you're given square root of 4x plus square root of 36x minus square root of 9x. Okay, so when you're given something like this, clearly what's under the square root is very different in all of these. So the objective out here is to simplify what's under the square root first. Okay, so in order to do that, we need to understand a few basic rules of radicals. So let's say you're given a radical of two numbers. So let's say you're given a square times b. So then, because there are two terms out here, and you clearly see there's a hidden square, right? Or rather, out here it's pretty obvious. There's a square, so a is squared. You can actually split this radical. So that can be written as square root of a square times square root of b. So see, you can separate the terms and put each of them under the same square root, okay? So now, if I take the square root of a squared, that's nothing but a, right? So a, and then I have the remaining, which is b. And that's exactly what we need to use in this kind of problem. So out here, I can immediately recognize that 4 is the square of 2. So I'm just going to split this. I'm going to write square root of 4 times square root of x, okay? And then 36 is the square root of 6. So square root of 36 times square root of x. And 9 is a square of 3, right? So square root of 9 times square root of x. All right, so what's the square root of 4? 2. leave this x under the square root, plus square root of 36 is 6, square root of x, minus square root of 9 is 3, square root of x. Okay, so now see, now I have the same thing out here, here, and here. Just going to go and shade, I'm going to go ahead and shade those. And so I just have to combine the coefficients now. So 2 plus 6 is 8, minus 3 is 5. 5 square root of x, and that is my answer. Okay? Okay, let's do another one. 3k square root of 8k square n plus 5k square root of 2n. All right, so now I'm going to adopt the same principle out here, okay? So I'm going to look for, okay, what's hidden? What's the hidden squares out here? Well, I could treat this, I could do it this way. So 3k, I'm going to split the 8 into 4 and 2, because 4 times 2 is 8, and the reason I split into 4 and 2 is because 4 is a square. It's a perfect square, right? And then I keep the k square as it and keep the n. And then the second term is 5k square root of 2n. All right. So now I know I'm going to take this out and take that out, right? So let's do that. So 3k square root of, 4k square times square root of 2n plus 5k square square root of 2n. Okay, so now see, that's a perfect square. So I can pull that out as 3k times 2k and then square root of 2n plus 5k square root of 2n. So 3 times 2 is 6, 6k square, right? So 6k square root of 2n plus 5k square root of 2n. Now I can combine them, see? Because that term is the same as that, so I can add the coefficients together. So 6 plus 5 is 11, k square root of 2n. And there you have it. That's how you simplify radical expressions. Thank you for watching.